Hello and welcome to this video. I am Karnesh Johri and this video is about concrete classes in C++. There are concrete classes and there are abstract classes. As the name suggests, concrete and abstract classes are opposites of each other. The key difference is that concrete classes can be instantiated, whereas abstract classes cannot be instantiated. We can create objects of concrete classes, but not of abstract classes. Concrete classes must not contain any pure virtual function. Abstract classes must have at least one pure virtual function. So abstract classes have to be subclassed and the pure virtual function needs to be implemented in the derived class. Concrete classes can behave like built-in types. The data members are part of the definition and objects can be created and initialized like the built-in types. You can have local variables on the stack for objects, pass objects by value to functions, and copy objects using the assignment operator. And if concrete classes implement operator overloading functions, you can use operators like plus, minus, star, slash, like the built-in types. In fact, concrete classes do better than the built-in types. For example, vector is better than array because its size is not fixed at compile time and error handling is better. Similarly, C++ strings are preferable to C-style strings. We'll have two examples of concrete classes. First, an arithmetic type complex, and second, a container class vector. This is an implementation of complex class. It is a concrete class. There are two data members which are two doubles A and B, and they represent the real and imaginary parts of the complex number a plus bi, where I is equal to square root minus 1. There are three constructors. The first one takes two arguments, creates an object of class complex, and initializes data members A and B to the arguments h and k. The second constructor takes one argument, creates an object of class complex, initializes the real part A to h, and the imaginary part B is initialized to 0. Then there is a default constructor with no arguments. It initializes real and imaginary parts A and B to 0. Now we have two data members A and B. There should be some way to read and write to these data members from the users of the class complex. For this, we have getter and setter methods. The getter methods read and report the values, and the setter method sets values. The first one, real constant, reads the value of A. It is a getter method. And next, real double H is a setter method which sets the value of A. Similarly, we have IMAG, getter and setter methods, and we have four operator overload functions for operators plus, minus, star for multiplication, and slash for division. Using these, we can add, subtract, multiply and divide complex objects. If we look at any of the four operator overload functions, they take in one argument. For example, complex operator plus, constant complex reference z, constant. There's only one argument z, and if we look at its usage in the main function, we see something like complex c1 initialized to x plus y. So how does x plus y happen when the plus overload function takes in only one argument? The answer to this lies in the fact that operator overload functions are non-static member functions of class complex. They are called for objects of class complex. When a non-static member function is executed, an implicit pointer named this is available, which points to the object for which the member function is being executed. So the first parameter is the object for which member function is being executed. When you see the statement C1 initialized to x plus y, the expression x plus y needs to be evaluated. The compiler interprets x plus y as x dot operator plus parenthesis y, which means operator overload plus for object x and add object y to it. So y is added to x and the result is used for initializing C1. Let us quickly look at the main function. X and y are two complex objects. X initialized to 2.0 real, 3.0 imaginary, and y initialized to 3.3 real and 4.5 imaginary. Then we have C1, C2, C3 and C4 complex objects initialized to x plus y, x minus y, x star y and x slash y respectively, and we print C1, C2, C3 and C4. Next we change the values for x and y and we recalculate and print. We can compile and run this program and it prints the results which are okay. Vectors. Our second example is vectors. A vector is a container of other objects. A vector stores its elements sequentially, much like an array, but it is not fixed size like array. Its size is dynamic. It can grow or shrink at runtime. In C++, vector is normally preferred over arrays and is in fact most commonly used container in C++. And here is an implementation of vector class. Looking at the program, first we have the data members. The size of vector is SG and the type of SG is size t, not int. The type size t is unsigned and is guaranteed to be large enough to hold the size of the largest object on the system, whereas int is signed and there is no guarantee about its size. So size t is preferred type for variables that hold size of something, and it makes our program portable. The elements are stored in an array and double pointer element points to an array of SG doubles. The constructor creates the vector from an initializer list of double. It creates an array of doubles of the size of the list, and SG is also initialized from the size of the list. The elements are copied in the array. The destructor deletes the elements, and there is the important operator overload function for the square brackets. With this we can access the elements of a vector, and there is the getter function which gives the size of the vector. In the main function we initialize vector v1 with initializer list and we print it in the for loop. We have looked at concrete classes in this video. You can find all this information at SoftPrayog website. Here is a QR code and the link is there in the description. Please subscribe to SoftPrayog, click on the bell icon and enable notifications. Thanks very much for watching. Take care and stay safe.